So my name is Florian. I'm a PhD student in France in the LCIS, and I will present to you my poster. So it is how to increase the coding capacity of Chipless RFID using the radiation pattern. So for Chipless RFID, we'll have a resonator like this, and the coding will be present if you have a peak or non-peak in the frequency band. So the idea behind this project is to use the same frequency band, but to encode multiple peaks. So what we proposed here is to use the loop resonator here. We know that this loop resonator can have this radiation pattern at the fundamental frequency and this radiation pattern at the first harmonic. So if we have a configuration like this, like this one here, with the tag working at the fundamental frequency and one tag working at the first harmonic, we will be able to have this response. So in blue is the long resonator frequency response, and in green is the short resonator frequency response. So we can see that, for example, in this slot, you have the blue and the green curve that are present, and you are not able to isolate them in the traditional encoding. So here you have measurements with 3 frequency slots. On the first frequency slot, you have 2 resonators, one long and one short. You can see that the S11 parameter allows to read only the long resonator, because at 90 degrees, which is the S11, you will have signal coming from the long resonators, but from the short resonator, we'll have no signal. This is why you only see one peak. But for the S21, which is on the side, you will get signal from this resonator, but also this one. This is why you have 2 peaks. But if you apply this formula, you will be able to isolate them and have the response of the first resonator in blue and the response of the second resonator in the yellow. So here we did a measurement. We were interested in this frequency slot, and we put 2 resonators. So the resonators were aluminum sheet cut by hand. In the S11 parameter, you can see one resonance. In the S22 parameter, you can see 2 resonances, but if you apply the equation here, you will see only the second resonance. So we proposed this approach, for example, for rolling cards, when you can have a configuration with B-static configuration, and this allows to have a constant frequency band, but to multiply at least by 2 the coding capacity.